All right. There we go. Sorry, this took me a minute to relearn how to use Zoom. So welcome everyone to 2021 semester, Biochem 2. Casey Andrews here. And today what we're going to do is we're going to go over the syllabus. We're going to go over how to use Blackboard, and we'll do some lecture material. So the way that I'm going to run the class this semester is I'm going to have live sessions Tuesday, Thursday, 12:30 to 1:45. If you cannot make it, or if you cannot make it for the whole time, that's fine. All lectures will be recorded and put up on YouTube. So these lectures aren't mandatory for you to be at. But if you learn better at being like at a live session, or if you want to ask me questions, that's what these are here for. If you're watching this on YouTube, or if you have questions later, always feel free to send me an email. Speaking about the live sessions, just for like security and ease reasons, I have everyone muted, and I took the permission away to let people unmute themselves, because I'm using like my general room without a password, so like anyone could come in. If you'd like to ask questions, if you want to put it in chat, that's totally fine. Or if you feel like it would be better for you to say your question out loud, just simpler for you, let me know and I can unmute you and you can ask it that way. Either way works for me. If you want to ask a question, but you don't want like everybody else to see your question, in the chat box, you can send a direct message to me. That way, only I will be able to see your message. So if you have any question, and I know one of the common things is that you don't want other people to see your question, you might feel a little embarrassed asking questions, that's a perfectly fine way to do it. I will usually repeat those questions out loud so everyone knows the question, but I will not say your name out if you send me a private message. All right, so let's get started with just the syllabus first. So let me share that. And if you have questions as we go, feel free to send it in the chat. Would you consider small time intervals of peer discussion throughout the live session? Yeah, so generally how I run my live session is I'm going to make periodic stops for questions. And we'll see this today, where I'll give people time to like answer the questions I pose. If you want me to put you in breakout rooms so you can talk about it, that's fine. If you want to chat to other people, that's fine as well. Yeah, that's totally fine with me. There are times throughout the lectures where we stop so you can do questions. And originally in a live person class, the idea is you would talk to the people around you, but you can do that here if you'd like as well. All right, so here's the syllabus, should be posted online and posted on whatever website we have to post these on. Like I said, class hours 12:30, 1:45, not mandatory. They will be put online. I put office hours on here. If you want to have a meeting, the best way to set that up is to use my email and tell me a time that works for you. My office hours here, I'm not going to be sitting in a room just waiting. But if you shoot me an email and you want to set up a time, we can do that. And if none of these times work for you, please do not feel restricted to only using these times. If you're wondering, the only times I'm really busy this semester are Monday, Wednesday, Fridays, 10 to 11 and 2 to 3. Then Tuesday, Thursdays for this class. Otherwise, I am not my time is not like put away for something else, like a meeting or anything. So please just, if you have questions, feel free to set up a meeting when you would like. The textbooks we're using is the same one for Biochem 1. So Fundamentals of Biochemistry by Vogt and Pratt. Unlike every other semester where I've taught here, we have done away with the ebook program. So the ebook does not come with your tuition. The homework does not come with your tuition. You might have access to it right now because I think the people at Wiley, what they did to set up my account is since we had the ebook program, they gave like, as long as you could have access to my Blackboard, you could have access to all their material. And I don't think they've turned that off yet, but just be aware if you don't have access to it for whatever reason, you have to purchase it yourself. And I'll show you how to find that when we go to our Blackboard site, because I'm sure some of you need a refresher since it's been a while since you've taken Biochemistry 1. It was still up yesterday. Yeah, so just be aware it might go away. I don't know how closely Wiley is looking at it, but they will probably figure out that they did not get a chunk of money from me for my class. So if you randomly, if you don't purchase it and you find you don't have access, that would be why. But yeah. If they never take it away, well, yay us, but just be aware of that. So what are we going to learn in Biochemistry 2? Biochemistry 2 can basically be called metabolism. We are going to dive deep into how cells, animal cells, we're not really going to look at plants, how animal cells and bacterial cells take energy from their environment and how they use that energy to build stuff. So that's about 3/4, I would say, of this class. We're going to look at all the cycles. We're going to look at all the enzymes of the cycles. We're going to learn the logic of the cycles, the math of the cycles. So it's very, very in-depth. Like in Biochemistry 1, that was very much an overview of here are the fundamental tools you need to understand biochemistry. And Biochemistry 2 is we're going to look at one subject that's applicable to many fields. So like metabolism is not the only subject of biochemistry. It's not something I personally studied as a graduate student, but it is a very important field. MDs, vets need to know all this. So we're going to do deep dives into it. The learning objectives, we'll look at some of the topics that we cover. Student responsibility. So best way to contact me is email. I will do my best to respond to you in a timely manner. If you email me late at night, just be aware that I go to bed somewhat early. So you probably will not get a response till the morning. If you email me on the weekends, it will be even more delayed as I'm not checking my email that often during the weekend, but you will probably get a response that same day, depending at where you contact me at. If you send me an email and you don't hear back within 24 hours, just send me another one. I don't find it annoying. Sometimes I get a lot of emails and I will read one without responding to it. And then it will, when I go to look at my emails, it will show that I've already read it. So I might just forget to respond to it. So feel free to bug me as much as possible. I need to update this. You are not expected to attend lecture. So attendance policy does not hold true for our online course. Conduct and behavior. So everyone should be respectful, no like vulgar language in the chat. If people get out of hand in the chat, I will definitely mute you. So just treat this like a regular classroom. So the grade distribution. So we have 4 exams, 17% each. final exam. And for the exam, I'm going to say this already. I usually like to tease it out. I'll drop your lowest exam. So if you bomb an exam, no, don't worry about it. I will drop it. Homework in this pre-class work / reading guides. And I'll go more into depth on that in a little bit when we look at the Blackboard site. But those of you who have taken Biochem 1 with me, this shouldn't seem unfamiliar. If you took it with me over the summer, some things have changed because the summer was a little different, but it's basically the same as always. Grade distribution, nothing too exciting there. So exams, when you get your exam back, if you have questions, and I'll repeat this, if you have questions about how I grade the exam, I ask that you talk more like one-on-one with me. Usually those type of issues, we don't need to have a whole classroom discussion about like, why'd you miss a certain point here or there? I will be happy to discuss with that either in a meeting or through email. All right, so pre-class work / reading guide. So before every class, and again, I'll go over this on Blackboard, but before every class section, I'm going to put up videos, and I just have a reading guide for you to follow to make sure you're watching those videos. If you want to type in your reading guides, or if you want to print them out, write on them, scan them, does not matter to me. All that matters is that I get them. And for these reading guides, I am not going to look to see if they're like correct or not. I'm looking for completion. This is the first time you are looking at this material. So I don't expect you to have all the right answers. But I do want you to try. So I'm going to be grading these on trying. So I will scan these periodically just to see. So if you just like turn it in and put like a bunch of smiley faces, you're probably not going to get credit. If you leave blank questions, I'm going to take some credit off. But if I just look through these and see people have given honest attempts, you get 100%. So that's 5% of your grade for just watching the videos and filling out those guides. Exam dates, I will try to stick to these as much as possible. So exam 1's on the 16th, then March 11th, April 6th, and April 29th. For the exams, I'm leaning towards using ProctorU again. I know it's not the greatest, and so I'm going to do a little more research into other options available to us. But yeah, no, I will talk more about that probably at the beginning of February, how we're going to do the tests. So some important things that's on every syllabus, accommodations. So if you have test accommodations, please go through DSS, Disabled Support Services, and they will give me the necessary documentation. I cannot grant you extra time on a test, only they can. So please do not come to me with requests for that. You will need to contact DSS. Academic Learning Center, I don't think there's a tutor for Biochem 2. Pretty sure about that actually. So if you have questions about Biochem 2, metabolism, come to me. I'll be happy to help. Counseling, there are free counseling services for you as a college student. The information is presented here. So if you feel like you need counseling of any sort, please do not hesitate to call them. There's also a 24-hour hotline here on the syllabus. Emergencies, you can get JAG-E alerts, our mass notification system for any emergencies that happen on campus. Financial aid, I'm not going to go through all that. I will be. So actually, let me just say, so we do have assignments due on Thursday, and then the following Tuesday, we have those reading guides. That's probably how I'm going to gauge attendance, because I need to report attendance with like the first week of class for financial aid. So do make sure you're doing that. If you don't do that or contact me in any ways, I have to assume that you're not coming to class, you're not attending. So you need to do those assignments. Writing center is great. I love it. We're not going to do a lot of writing here. So we don't need it for this class, but any writing, please do see them. Military affairs is always there for you as well. Patriots Casa 202, or you can contact them through the email or phone number provided. Religious observances. So if you need to miss a period due to a religious observance, just let me know. That's usually fine. So yeah, you can make up exams if that happens. Respect for diversity. Again, that just goes to the whole being respectful in the classroom thing. 6 drop rule, you can drop up to 6 times during your undergraduate career. Sexual harassment and discrimination. I am a mandatory reporter, so if I hear anything about sexual harassment or discrimination, I do have to report it. So even if you want me to keep it confidential, I legally cannot. So I will have to report that. So just be aware of that. Student rights and responsibilities. Again, this is on every syllabus, so please do feel free to read this at your leisure. COVID-19 syllabus. So we're not meeting on campus, but if you are and you are feeling sick, especially with the new strain going around that's way more contagious than the regular strain, so now we have super COVID around, please do not show up. I think yesterday or a couple of days ago, I saw in Bexar County, there was like 3,000 new cases. So it's in the stage of just being spread uncontrollably in the county. So if you are feeling ill at all, do not show up. If you do have to go to campus, make sure you have your face mask on. Make sure you go and get your temperature checked. Although honestly, with this virus, I'm sure you all know this, but you can spread it without being sick. So that temperature check is no more than like a comforting pat to everybody. So just be aware, wash your hands, keep 6 feet away, have your face mask on. You should be safe for the most part. All right, so some key dates. Today's first day of class, 26. If you want to drop this class with an automatic W, that's the 26th. The 30th is the last day to drop the class at all. 3rd and 4th of May are your reading dates where you don't have class and you can study. And I do not know the final exam date yet, but I'll let you know when it is. I just want to go back to one other thing that I remembered while going through this. So for these exams, I generally do not allow people to take exams late. What I will do for those exams on that date, I will open up the exam on Blackboard for 24 hours. So like on February 16th, you can start at 12 a.m. February 16th, and you have till 11:59 p.m. on February 16th to really do your exam. So I give you flexibility there. If you know ahead of time that you're not going to be able to be online during one of those exams, let me know and I'll gladly give it to you earlier. That's no problem with me. All right, so that's our syllabus. Going through that lovely information, is there any questions or anything people would like for me to go over more in depth? And if not, we can go to our Blackboard site. All right, so if you are typing a question, feel free to continue typing. Otherwise, I'm going to transition to our Blackboard site here. Show you where everything is, in case you forgot. There it is. All right, so we are in biochemistry 2. All right, the main areas of this site is course content. This is going to be where you use the site the most. You can see here we have dated folders, January 19th, January 21st, blah, 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 all the way to currently April 15th. So there are some more folders I have to make, but most of the semester's already up right now. Let's go to the 21st. For every date, I have PowerPoints. I have videos that go over those PowerPoints. Then I have your reading guide. So for Thursday, what you're going to want to do is you're going to want to download this reading guide. You're going to want to watch the videos. And if you like to watch videos and take notes on PowerPoints, that's why these PowerPoints are here as well. And you want to fill out this reading guide. Once your reading guide is done, put it in, turn it in, and do that before 12:30 on Thursday, Jan 21st, and you will get full credit. One thing is make sure you get that email confirmation from Turnitin. There have been issues last semester where people said they turned it in, but they never got the email confirmation. And when I marked them down for a 0, they said they thought they turned it in. So just double check that. If you want me, if you put it in and like you didn't get an email confirmation and you notice that, feel free, shoot me an email and say, Dr. Andrews, I thought I turned it in. Can you double check for me before class just to see it? And I will be happy to do that for you. So that's going to be the bulk of your, or a good amount of your time before coming to lecture. And the reason for that is when I make the lecture that we go through class, I'm going to just talk on the most important bits. But these videos have the complete picture or the more complete picture of what's going on. And if you want even more in depth, what I would suggest is that you also read the textbook to get this material better ingrained. The more ways you see this material, the easier it is for you to learn. So read it, listen to it, and then go through class and do it hands-on. Hopefully the goal is by putting in all the time spread out through the semester, you won't have to spend like 10 hours the night before the test cramming. It's going to make studying for the exam easier. And this is really how you incorporate new information into your mind. And hopefully, if you're taking biochemistry 2, you already have those good skills because that's mainly what college is. College isn't really for you to learn like this information. It's more showing you how to incorporate new information, how to learn. The best thing you can do when you come out of college is that you know how to learn by yourself. You know how to find new stuff and incorporate it into yourself. And I'm trying to show you a guide at how I would do it. Spread stuff out, make sure you're writing when watching the videos and so on and so forth. Then when we go into class, or what we're going to do actually in class, are in these folders called test 1 or test 2 in class. So inside these folders, I have our dated PowerPoints. You can see I have 2 in there right now. Tuesday, January 19th, Thursday, January 21st. These are the PowerPoints I'm going to go over in class. These will have various questions on them that we're going to do together in class. So I will have another folder called Test 1 in class with answers. There I will have the answer keys for what we go over in class. So when studying for the exam, make sure you go back to these Test 1 folders and you are confident that you can answer those questions we went over in class, because that's going to be the first thing I look for when I make the tests. I'm going to relook at those questions and use those for my inspiration on how to do the test. Because my philosophy on the test is I'm not trying to trick you. if you want a baseball analogy, I'm just going to be throwing fastballs, no curve. Just see if you can hit it. You practiced it. See if you really understand it. So for every test, there will be a different folder. This is also to help with your organization, because one of the big questions I always get is this going to be on test 1 or test 2? It will be in the folder. If it's in the test 1 folder, unless I make some other declaration, it's going to be on test 1 and test 2. All right. So any questions about the course content folders or what's expected from you day to day? All right, if not, I'm going to show you Wiley Plus. So to get to Wiley Plus, which is our homework system, you go to Tools, which I did right there, and you want to go to Wiley Plus. Here you'll have the assignments. That's going to be where you usually want to go to. That will have the assignments. And what I'm going to do is after every time we do a session in class, I'm going to assign a homework to it. Now I'm going to do something different than I've done in previous semesters. Usually, I've always made this due on Sunday. What I'm going to do now is your homework's always going to be due a week from when I assign it. So for example, if I give an homework assignment today, that assignment's due on the 26th now. You have a whole week to do it. Then the homework I assign on Thursday, the 21st, that assignment is due on the 28th. Hopefully, this will give you more flexibility during the semester to do your homework at your own pace. A week should be enough time to find in your schedule to do the homework. Yay, yeah. I was kind of thinking that Sunday thing is arbitrary already, and so I'll give you a week. So I shouldn't have any excuses of something happened this weekend, I couldn't get to it. Well, now you have 7 days. So if something happens on like day 6, and it's like, Dr. Andrews, on the Monday before the homework was due, something happened, I couldn't do it. My response would be, you had 5 other days to do it, so now it's late. So with that flexibility comes responsibility. So just be aware of that. All right. Also, read, study, practice. This is where your ebook will be if you have an ebook. If you want a hardcover copy, that's totally fine as well. I know some people like hardcover copies other than ebook. So any questions about Wiley Plus before I move on to our next thing? All right, the last thing is the grades. So I think everybody's had me before, because I don't think anyone took Biochem 1 at a different university and then came here. Hopefully I'm not wrong about that. But you should see the grading class. That should be familiar to everybody. That will be your current class grade. This will update in real time when I put in assignments. The reading guides, all the Turnitin things, they do not have a real grade, right? So these things will remain blank, and I will try to remove them as I update the, as you turn stuff in, I will probably hide these from your view, and I will make a new column all the way over to the right where I'll score the reading guides between 0 and 1. So when in like a month from now or 2 months from now, if you see like your grades aren't so hot and you email me saying, I turned in all my reading guides, but they're blank on the grade sheet, just remember this little tidbit. The Turnitin grades are like fake. Those aren't counted. I create a new column for those. And I think that's pretty much all you need for the Blackboard site. Announcements, of course, are important. I will try to remember to update my professor or whatever tab it is, so it has my real email address. Just remember C. Andrews or Casey.Andrews will get to me. But before we actually go on to lecture material, this is not just syllabus dead day. Before we get on to lecture material, are there any questions about anything I went over? So these meetings are just more elaborating on the reading guides. And then you said the test one. So these meetings are what your lecture would be if you were in an in-person class. So these are like more or less one-to-one what a real lecture would be, other than you can't really talk to the people next to you all that well. And the in-class test one folder, that's our PowerPoint for what we do in these sessions. And these will have like extra questions that we're going to go over together as a class to make sure we all understand the information. And then when I go to make the exams, these are going to be the first things I look at to make the exam. Now, I do have the right to go into the videos and pull out information for those for the exams, but the majority of the exam will not be that. The majority of the exam is what we do in these sessions. So it is important for you to either attend these sessions or watch the video on YouTube. And if you watch them on YouTube, feel free to put it at 1.25 speed. Don't put it at like 1.5 or 1.75. You're going to have a very hard time understanding what I say. Do you have any chance how much the cost would be for Wiley when we no longer have access? That's a good question that I should know, but I only looked at the Gen Chem. I want to say it's usually $60, and the ebook plus this is like $120. Because I did look at it on the weekend. I just can't remember the number offhand. I can make a note of that though. I will get that information to you. Let me make a note here. Just looking, download Wiley Plus from the site and said the course is still integrated. I don't think we can download it yet. Yeah, so my course will be integrated, so I don't think. So I don't think you can download it unless you. Yeah, I can contact the Wiley Plus rep for that, because this is the first time we've ever done this way. We've always used the ebook program before. So it was super simple from my point of view, in that I didn't have to do anything. It was already set up. So let me see about that, because you should be able to access Wiley from Blackboard, but I don't know about like downloading things. Or how to purchase Wiley Plus. You followed the posted link, but it didn't see a purchase page and kept that. So yeah, I think that was my error, in that I didn't realize Wiley Plus is set up either like you integrate it or you don't. And so I'm going to use integration because it keeps everything on one side. So the way that will happen is that you'll need to go to Tools and go to Wiley Plus. And then you'll go to Read, Study, Practice. If you don't have access, in my experience, that's when it'll usually say, you don't have access to this, please buy it. And then once you do, it should already be linked to my class, because you went through my class to get to the information. At least that's how my other textbooks work. Right now, we're in a weird period where Wiley didn't turn off the ebook access yet, where everybody still has access to it for free. So hopefully that would be amazing if that continues for some reason. But just be aware that it might not, and you'll probably have to go through my Blackboard to access it. It might also be that there's like a 14-day free trial on for people. I'm not exactly sure. all new for everybody. Okay. Anything else? All right. So I'm going to pop open the PowerPoint. And again, if you want to follow along, this will be in the test one folder, Tuesday, June 19th. And today is going to be basically review. Don't need those. And we're going to just review some basic biochemistry/chemistry concepts. Display setting. Okay, there we go. So first off, this is a question I get a lot because we only offer Biochem 2 once a year because the turnout is usually low. Like I think my second year running Biochemistry 2, I had 3 students. Luckily now we're building up the biochemistry student base, so we have more than 3 students. But yeah, it's still not enough at this point to run it every semester. So some of you, it's been a year plus since you've taken biochemistry. And the question is, what should I review? If I forgot all about biochemistry, what should I look at? Okay, so these are the things that I would say you would want to review. You want to remember your carbohydrate structures. Remember what glucose looks like. We are going to talk a lot about glucose. So you want to know what glucose is. You want to know basics about what carbohydrates look like and their basic function. Enzymes. We're going to talk a lot about enzymes. So basically, what is Michaelis-Menten? How does that work? What's an enzyme? What's an active site? So just those terms. And you will want to refresh yourself on amino acid structures. I'm not going to do the same thing in Biochem 1 where I'll give you a bunch of amino acids and ask you on a test, what are these? Hopefully we're past that point already in our studies, but I know you guys aren't like me. You don't think about amino acids on a day-to-day basis, so you probably don't have these like stone cold memorized. So just review, refresh yourselves. Remember, what are the negative ones? What are the positive ones? What are the polar ones? Just review yourself on that. And you should have a good basic some of the stuff we're going to cover. But for the rest of the time today, we're actually going to look more in depth on some thermodynamics and some ideas about nutrition. Since we are talking a lot about metabolism this semester, we're going to start with a very macroscopic view of nutrition. And what is that? It's the intake and utilization of food. So it's eating and how to use it. Depending on how you get your nutrition, you are called different things. So if you're an autotroph, you can make everything yourself through simple compounds. Auto, right? Like an automobile kind of moves itself. So an autotroph makes things themselves. Now, if you're a chemolithiotrope, you get this energy through inorganic compounds. So chemolithiotropes are usually bacteria, right? They're going to get energy from things different from us, NH3, H2S, iron. So for the most part, we are not going to talk about chemolithiotropes this semester. We are going to focus on animals. So animals use organic matter. So it's important to know that chemolithiotropes exist. We're not going to focus on those. Some further classifications, you have your photoautotrophs. These are going to be your classical plants. They use photosynthesis, get light energy, They transfer electrons to carbon dioxide. From there, they make the carbohydrates, like the glucose. And our heterotrophs, we take organic compounds, we oxidize them, and we are dependent on autotrophs. So we're going to focus on the heterotrophs this semester. Not really going to talk about photosynthesis at all. If you are interested in that, we have a very good plant biologist here on campus, but I am not that. So we're going to focus more on heterotrophs here. Further classifications. So you have your obligate aerobes. Those are creatures that must use oxygen. So that's us. We need oxygen. You have your anaerobes, which doesn't use oxygen. They can use sulfate or nitrate in place of oxygen. Facultative anaerobes, you can grow with or without O2. Or your obligate anaerobes, you are poisoned by O2. And we will see in this semester how dangerous oxygen is. Even for us, we are obligate aerobes. Oxygen is still really bad for human cells. It's extremely poisonous if we do not handle it very carefully. So we're going to look at the systems in our body to make sure that oxygen doesn't ruin us. And actually, one of the theories for why we age is because of oxygen. Through doing metabolism, we use a lot of oxygen. That oxygen is poisonous. And so it breaks down some of our cell components, and we see that in the form of wrinkles, right? So animals, us, we're obligate aerobe heterotrophs. And nutrition is balanced intake of proteins, carbohydrates, and lipids. And we're going to see how this is all interconnected, how you really do need this balanced diet, this balanced intake to keep a functioning organism. Because if you have one over the other, what will happen is that you'll accidentally poison yourself because of all the byproducts you make. So it's very important to keep this balanced diet. Then we need other things like oxygen, water, vitamins, minerals. So what's a vitamin? A vitamin is just an organic molecule animals can't make themselves, and we need it to get from our diet, either water soluble or fat soluble. Water soluble are converted to enzymes. And the bottom part is cut off on your PowerPoint, but it just says we need minerals and trace elements. For example, we need iron, right? We need zinc. We need magnesium. So we need some metals in our diet. Very, very, very small amounts, but we need those for our enzymes to work. So our first question of this semester, and I want everybody to take a minute and think about this. Why does a heterotroph need vitamins, and why does an autotroph not necessarily need vitamins? Just a very simple question to start the semester out. So just take a few seconds and think about this one. They get vitamins from the sun. Not every autotroph. How about chemiolithotrophs? They're autotrophs. You're thinking of photoautotrophs. Remember, life is more complex than just plants. From the dirt, I mean, kind of. The idea, heterotrophics may not get all the elements they need otherwise. The idea is, remember, autotrophs can make the things they need, right? So chemolithiotrophs, they don't use the sun to power their metabolism, right? For example, those that live on the bottom of the ocean floor, they can use sulfur vents, right? They use the power of those sulfur vents to do their chemistry. They're so far down the sun would never reach them. So autotrophs can make it. Heterotrophs cannot. So heterotrophs need to eat things to get these vitamins. From the heterotrophs can't make it, so they eat it. Yeah, so we can't make it, so we eat it. From the process of metabolism, how certain organisms use the energy obtained. What we're talking about here is actually catabolism. Anyways, we'll get more than that in a few lectures. But here we're talking about making things. Heterotrophs cannot make everything they need. That's why they're heterotrophs. Autotrophs can. So using like the sun, for example, and getting nutrients, they can make vitamins. Heterotrophs, you need to eat your Flintstone gummies to get all the vitamins. Actually, you just need a balanced diet for the most part, but same thing. Yeah, metabolism, anabolism, and catabolism. Yep, we'll get into all that good stuff. All right. Question 2, a little more in depth, but not really. And I do have a Zoom poll for this one. And this will be our first introduction to Zoom poll. So when I go through certain problems that I can create a simple answer for, I will pop up a Zoom poll. And when you answer Zoom polls, the way I have it set it up is that no one else can see your answer. I can't see your answer. Well, I can just see the percentages. So do your best to answer those. This is a way for me to gauge people's understanding of how fast people answer questions. So I'll pop that up in a second. But first, certain organisms, methanogens, they're prokaryotes, and they make methane. While some bacteria consume methane. So A, please tell me, are these bacteria autotrophs or heterotrophs? And this is what I have to poll for. So just to get you started, here's a simple question. Are the methanogens autotrophs or heterotrophs? And are these other bacteria autotrophs or heterotrophs? Just from the information given. Then B, rather simple. Why are these two types of bacteria often found with each other? You're saying autotrophs just because they make water? We also make water. If we didn't make water, we wouldn't pee. Actually, that's not true. That's a big lie, but we do make water. We don't make a lot of water, but we do make some through our chemical reactions. All right. Yep. Byproducts of enzymes or side reactions a little bit. So methanogens, they are autotrophs. Granted, I didn't really give you enough information to say that 100%, but they are making the methane themselves from hydrogen and carbon dioxide, while these other bacteria are definitely heterotrophs. They are using that methane and consuming it to do different chemistries. So methanogens, from the information given, they are best classified as an autotroph. You can make the argument, well, we don't know they're autotrophs because you didn't tell us enough information. Are they getting energy from it? Sure, I'll buy that. The other bacteria, though, would most definitely be heterotrophs. So the majority of us got that. And why are these two bacteria found with each other? Well, one makes methane, the other one eats methane. So wouldn't it make sense that the thing that eats methane be found next to the thing that makes it, right? So yeah, That's rather simple there. How can you tell just from the equations? Well, it's more the idea of what's happening here, right? So the methanogen is taking hydrogen and carbon dioxide, and then we're making methane from that. So we're taking things from the environment and we're building up on that. And usually you can use that methane to make like energy for some organisms. So that's kind of what's being shown in the second equation. Other bacteria can take that methane, break it down to make different components. And from there, you will get some energy from it. Not the best question in the world now that I go over it again, but it's more the concept. I'm taking things from the environment and I'm building the things I need. So I am an autotroph for the most part, as long as I don't eat like other organisms to do it. And as long as I can produce it myself, I'm an autotroph. Heterotroph says, well, I need to take something because I can't make it. So I'm going to take that and then I'm going to use it to do other things. So that's kind of the idea I was going. At the end of the day, make sure you know the difference between an autotroph and a heterotroph. That's kind of what I was trying to get at with this question. Do we know what an autotroph means? Do we know what a heterotroph means? The equations are just there to show you what's happening for the most part, I would say. All right, so that's the basics on nutrition. And what we're going to look at this semester are metabolic pathways. We're going to go over pathways so much, you're going to be so sick of pathways by April. We're going to look at these pathways in depth. But the good thing about this is once you learn one pathway, you will notice all the other metabolic pathways in the cell, they have the same ideas that just keep on repeating on each other, right? And that sentence will make more sense once we start learning about the pathways. But the different pathways, they use the same basic ideas of chemistry and physics to do different reactions. And so once you learn one pathway, the other pathways will become easier because you've already seen these ideas before. Just some vocab for us. Metabolites. When we talk about metabolite, that's any reactant, intermediate, or product that's used in metabolism. So it's really a catch-all word for anything used in metabolism. And currently, we know of over 4,000 metabolic reactions. And these reactions are done by unique enzymes. In this class, we might look at like 50 or 60 of these reactions. Just know there are a lot more that we're not going to talk about. Depending on where you are as an organism, what stage of life or development, the enzymes and metabolites inside your cell will be different. This is very important if you're doing like single cell studies. You'll see during different growth phases, the metabolome changes a lot. And when we look at these pathways, we're going to see that certain players, certain metabolites, they appear a lot. The metabolome inside each one of your cells is highly connected. It's very branched. There's many different paths, but a lot of them are like all connected. So it is very complex how a cell uses energy. And breaking down and building stuff are also connected a lot. Pyruvate shows up a ton. Acetyl-CoA shows up a ton. Yeah. Oh no, my picture that I put on there this morning didn't save. Let me just pull up. Sorry, one sec. I'm going to pull up something that I found on the internet. There we go. That's fine. So let me share my Google again. or my Chrome. So here's an idea of the metabolic map inside your body. This is simplified itself. Each one of these big things is a different metabolite. All these small things that you probably can't see, these things are enzymes. 2723 is an enzyme. 1213 is an enzyme. These are different cofactors, ATP. And you can see metabolism is very complex. Everything's connected. What we're going to learn this semester is glucose going down this main pathway here into acetyl-CoA, into ATP. And then we're going to do some byproducts of amino acids and some fatty acids over here. So we're going to look at the middle of this and some branching pathways, but we're not going to look at all of it. If you want a more impressive looking map, here's one from like a decade ago, which is out of date. And it's on Pinterest, but it's out of date now. Oh, can I make that bigger? I don't use Pinterest. Anyways, once you look at like full ones, they get super confusing because there's so much writing on them. But that's how interconnected our cells are. Yeah, so don't have a panic attack. We are going to look at it step by step. By May, you will have, I don't know, 10% of that map down, maybe 5, something like that. So we're not going to look at all the side reactions, but just realize, especially when you look at like advertisements for like supplements and vitamins and like power foods, like due to biochemistry, we have unlocked the power of the guava berry or whatever. Just realize everything is way complex inside the cell. So even though we are learning these pathways, we're learning it simplified, and we are cutting out a lot of the interconnected pathways from this course. Otherwise, this course would take like 4 years. So just be aware of that. It's very complex, but we're not going to look at everything. All right, let's go back to the PowerPoint here. All right, pop that back up. Bachelor's in metabolism. PhD in metabolism. That's what you need to get if you want to understand it. All right. So, one sec. So, catabolism. This is breaking down things. And usually it only makes a couple of things, which is really convenient for us. So acetyl-CoA, we're going to look at the citric acid cycle, which oxidizes acetyl-CoA to CO2. So we're going to look at that in depth. Throughout all metabolism, we're going to talk about redox reactions. So I know it's been a while since Gen Chem 1. So let's remember our acronym here. Oil rig. So when we talk about metabolism, oxidation is loss of electrons. Reduction is gain of electrons. So if something is oxidized, it's losing electrons. If something is reduced, it gains electrons. Metabolism is just basically a giant redox reaction inside your cells. And we're going to look at that in depth. So don't forget those terms. We're going to look at how electrons, basically how metabolism works. And I'm sure you've learned about this in some of your other biology classes. Our goal here is to get electrons to oxygen to make water. And the idea is we're going to control how those electrons move throughout the cell to make ATP. So we are basically little power plants using electricity to get energy. And we control that flow of electricity in a way that is beneficial to us. To make stuff, we basically do the opposite of breaking it down. And the general idea of this is that we have a few starting material, glucose, proteins, fats, and we use that to make just about everything we need inside the cell. A big player, and I know it's cut down again, acetyl-CoA. This is what acetyl-CoA looks like. So you can see we have our adenosine right there, 2-phosphate, coenzyme A right here. So we're going to see that a lot. I don't need you to memorize that structure, so don't worry about that. Just wanted to show one of our players. So the current graphic is kind of overview, or speaking of the side pathways. It's a very, very, very simplified view, right? This is just saying how proteins, sugars, and lipids are fed into the main pathway of glycolysis in the citric acid cycle. All the other side products are like, how do I make amino acids? How do I make different fats? How do I break down different amino acids? How do I break down different fats? How do I make nucleotides? How do I break down nucleotides? Every single different metabolite has its own like pathway for the most part. Those are the side reactions. And there's a lot. We'll look at some of the big ones. But if you have your ebook or your book, feel free to go to like chapter 21, which is the breakdowns of amino acids. Give yourself a little mini panic attack there of like the complexity. I'll try to make it as simple as possible. We'll go through this together, but it is complex. There's no way around it. All right. So I realize people probably have not done redox reactions in a long time. So we're going to remember how to do redox reactions. I'm going to do 3A for us, and then I'll let you do 3B to see if we remember how to do this. So let's just focus on A. I want to know if I'm showing a reduction reaction or an oxidation reaction. Or is the carbon I put the blue star next to, is that being reduced or is that being oxidized? Right, so we need to relearn the lessons from Gen Chem 1, which for some of you probably feels like 20 years ago at this point. So the first thing we need to do is give oxidation numbers. So I need to give all my elements oxidation numbers. For biochemistry, this is super simple because we only use like 5 elements: carbon, oxygen, nitrogen, hydrogen, maybe like 7, sulfur, phosphorus, right? We're not like Dr. Shelton. We don't care about fluorine. Fluorine's never going to show up. We don't really care about iron all that much. Sometimes it's a bit player, but usually when we talk about redox reaction, we're talking about carbon, oxygen, nitrogen, hydrogen, sometimes sulfur, sometimes phosphorus. So the rules for us are super simple. Every time you see an oxygen, this gets a redox number of -2. Every time you see a hydrogen, this gets a redox number or an oxidation number of +1. Carbon does not have a set number, so we have to figure carbon out. And the molecule, when you add up all of the numbers together, have to equal the charge shown. So that's our other rule. It has to equal the charge shown. And lastly, the rule is treat carbon separately. And I'll show you what I mean by this. So our first compound right here, top left, we have 4 different carbons. So we have to figure out the redox number. What I mean by figuring out the carbon separately is I'm going to treat each carbon as like its own molecule. Whatever's connected to that carbon, I'm going to treat it as its own molecule. So our redox numbers, we said oxygen, and I'm going to get a different color now so you can see this better. Oxygen, did that show? Yeah, oxygen is -2. No matter what, 99% of the time, oxygen is -2. So if that oxygen is -2, that oxygen is -2. You can see in this box that the overall charge of COO is -1. What that means is that carbon plus oxygen, all of their redox numbers have to equal -1. Well, if oxygen's always -2, and if oxygen's always -2, for our top element there, COO minus, what is the oxidation number of that carbon? Anyone can feel free to shout that out. It is a +3, yes. So that carbon has an oxidation number of 3, +3. Yep, 3 minus 2 equals -1. Positives and negatives matter a lot here. Okay, second box, we have 2 hydrogens. Hydrogen's always +1. So if we have 2 of those, carbon plus hydrogen, we don't have a charge symbol here, so that all has to equal 0. Hydrogen's +1, hydrogen's +1. Everybody, what's the charge of that carbon then? -2, correct. That carbon is -2. All right, next carbon, the one we care about, oxygen's -2. There's no charge, so that carbon's +2. And the bottom one's the same as the top one, -2, -2, +3. All right, that's how you figure out oxidation numbers for like carbon, oxygen, hydrogen compounds. Super simple. Then let's just, I'm just going to focus on this other carbon now, because that's the only one that changes. So that's the only one whose oxidation state will change. I'm going to redraw it out over here. Carbon, hydrogen, oxygen, hydrogen. All right. So hydrogen, always +1. Oxygen, always -2. If I look at this box, there's no charge, so that has to equal 0. Therefore, that carbon has an oxidation state of 0 because the hydrogens and oxygens are already making 0. So that carbon is 0. So let's look at the change here. We went from a +2 charge on our carbon to a 0 charge. And let's remember our acronym. Oil rig. Oxidation is loss of electrons. Reduce is gain of electrons. Who can remind us what is the charge on an electron? I even wrote it right there due to habit. What charge does an electron have? -2? Not -1. It's only -1. Yep. So if I went from +2 to 0, did I gain electrons or did I lose electrons? You gained electrons, therefore you are reduced. A is a reduction reaction. All right, so with the time we have left, see if you can figure out B. Do we have a reduction or do we have an oxidation? If you have questions about that, please let me know. I believe I have a poll up for this. Yeah, I do. So with the polls, if it gets in your way, feel free to move it or minimize it. If you minimize it, you can find it, I believe, at the top of the screen again. But for B, see if you can figure out if our carbon here is being oxidized or if it's being reduced. So I'll give everybody a few minutes to work on that, and then we'll call it day 1. And again, as always, if you ever have any questions while doing this, feel free to ask me. If you want to ask a general question in the chat for other people, that's fine too. If you want to work with other people, have breakout rooms, that's fine too. Remember, even though we are all like separated via computers, this is still a community where we're trying to learn Biochem 2 together. So hopefully doing these sessions or watching it online, hopefully you feel connected somewhat. All right, so we are running out of time here. If you're still working, that's fine. But from the results I have so far, looks like we have a split. Half, okay, now we have just about everyone answering, and it's still a split. 4 say oxidized, 5 say reduced. So I'm going to do this, show you this one. Hopefully that will clear up the confusion a little bit. So here are a compound on the left, hydrogens +1, hydrogens +1, oxygens -2. We just saw this one right here. It's the same compound, carbon 0. All right. Remember, treat everything as a separate unit. Even though there's a double bond here, this carbon is by itself with the hydrogen. So +1, -1. That carbon has a oxidation state of -1. So I went from 0 to -1. I became more negative. I gained electrons. So I am reduced. Yep. Reduced. All right. Any questions about that before we call it a day? And we have more practice on Thursday. We're just going to do a little more redox practice and then move into everyone's favorite topic of thermodynamics. We start with math heavy this term, and then we don't really do math much after that, but make sure you have your math boots on for the first couple of weeks. All right, so if there's no questions, that's all the time I have for today. As always, if you have questions, let me know. If you'd like to review this stuff, the video will go on YouTube. I'll upload it after we're done, and I will put this link in the dated folder. So the lecture from Jan 19th will be in the Jan 19th folder. Lecture from Jan 21 will be in the Jan 21 folder. So that material is always there for you to review. Otherwise, hope you have a good rest of your day. Hope you have a great semester, and I hopefully will see you later. Have a good one, everyone.